Okay, good morning, everybody. So today we'll be talking about concept called AWS Lambdas. So in the beginning of the course, we talked about the types of cloud computing, right? We talked about infrastructure as a service, we talked about platform as a service, and then software as a service. So AWS Lambdas come into sort of platform as a service, okay? And in fact, they kind of gave a separate space within that called function as a service. So it might sounds fancy, but let me explain. So simple, okay? Lambdas is nothing but Lambda. Essentially, AWS Lambda is nothing but a simple function that you write the code, upload to AWS, and then you just don't have to worry about where it gets deployed or how it gets deployed. So it is a serverless function as a service. You write a function, you write your code, okay? They provide some runtime environments like Java, C#, Python, Node.js, Go. So these runtimes they provided. You just write a piece of code according to the contract. They'll say that it's like your interface, right? So interface is the contract in your Java world. So even otherwise, you just write your function. Function is a contract, right? So what's the input? What's the output? So they will define. You have to have. Let's say if you're writing in a Java programming language, then you have to implement this interface, and then this interface has a method. Okay, you have to implement that method. Okay, so you write your piece of code that gets triggered based on some events, and then deploy your code in the cloud in your AWS, and then configure your configure your triggers. So when do you want this this Lambda function to be called? Do you want it to be scheduled, like to run it every minute? You can do that. Or a specific events. When I upload a file in one of my S3 buckets, I want this Lambda function to be triggered. You can do that. So this helps with the event-driven architecture. So the interesting point here is that there are no EC2 instances that you don't you have to worry about. Okay, and you are not paying for the servers, the unused time of the servers. Let's say your function is called only 5 times a day, and each time it gets invoked, it runs for 2 seconds. So total 10 seconds. You'll be paying for 10 seconds of Lambda execution. That's the beauty of it. You're not paying for 24/7 like your EC2 instance. So there's no active server. You write your piece of code and you just deploy it. When event gets triggered, this Lambda function will be invoked. Okay. So when event gets triggered, this Lambda function will be invoked. And at that time, when a Lambda function gets triggered, it will take your piece of code. Under the hood, it creates something called containers, a small lightweight container. It creates it. It's like a server, but it's not. Server is, virtual machine is too big for that. So it's a lightweight container. It creates it. Deploy your piece of code there, and then run your function. And you will be paying only for the computing that you're using it. You will not be paying for the 24/7 like in EC2. So it's a serverless technology. This is the new breed of technology. And in 2020, if you're building a brand new application, think about events, think about event-driven architecture, think about serverless technologies. Okay, this makes serverless web applications possible also. So AWS Lambda lets you run your code without provisioning or managing servers. There is no provisioning of EC2 instances. There is no provisioning of or managing of the servers. You don't have to worry about it. You pay only for the compute time you consume. If you're consuming 10 seconds, then overall for the day, just you pay for the 10 seconds. Just write your code, upload your code, and Lambda takes care of everything required to run and scale your code with high availability. It automatically takes care of distributing it across the availability zones in case the availability zone is down. You don't have your availability issues. So your Lambda is going to be highly available and you don't have to worry about it. And it will automatically scale. You can, your Lambda function may be called 5 times the whole day or 5 million times. You just set your limits there and it will automatically scale. You don't have to worry about the auto scaling loop and the EC2 instances, everything. This is serverless. You don't have server there. You just set up your Lambda, upload your code, set up your triggering points, and that's it. You don't worry about it. You worry about your business rules. What should I do when this function is called? That's what you should worry about it. And then configure when should this be called, meaning what events should trigger this execution, this Lambda execution. That's it. So you can set up your code to automatically trigger from other AWS services, meaning like your S3 events. So when you upload an object in an S3 bucket, you can have this Lambda triggered. Or your DynamoDB. So when a new record is inserted into your non-relational DynamoDB, then you can have your Lambda function triggered. There is a concept called API gateway. We'll take a look at that right after Lambdas. But API gateway can trigger it. That makes, the combination makes serverless web applications possible or serverless mobile applications possible. So this comes under function as a service category because you are defining a function and you are not worrying about the runtime. You are not worrying about the servers, managing the servers, provisioning servers. You don't have to worry about it. That's the beauty. And it supports a lot of runtimes actually. So before we proceed and taking a look at where can I use this Lambda, but first let's step back and talk about industry's trends. Since early 2000s until 2020, in the last 20 years, what's been happening in the industry? Let's take a holistic view, holistic look at what's been happening, right? So initially, you had your physical machines. If I need an Apache, then pretty much I need a brand new physical machine. That's how it's all started, right? And then we got this concept of virtual machines where you can virtualize your hardware. There are tools available out there, and you know that. So you can virtualize it, and using the virtual machine, you can spin up your instances. So one physical machine can be virtualized into multiple virtual machines. So EC2 comes under that category. We saw that, and we created a lot of EC2 instances, right? So later, few years back, this whole concept of containerization came into picture. So what this one does is, hey, I know what my runtime is. My runtime is going to be Java, JVM. Okay. So I don't need this, host operating system. I don't need operating system on every single virtual machine. I don't need a virtual machine. I need one, one operating system is enough. Okay. But within that, I need segregation. Within that, I need segregation. So that's where the concept of containers came into picture. Things like Docker. Okay. And then even Pivotal Cloud Foundry, that's container orchestration also. And we have Docker is a very good example, and Kubernetes is there. Kubernetes is their container orchestration. Okay, so essentially here in the containers, what we are saying is, in fact, Amazon also has some container platforms, Elastic Container Service, ECS, and EKS stands for Elastic Kubernetes Service. And AWS also has a service called Fargate that will abstract out things like Kubernetes. Okay, I mean, so you don't have to get logged with specific AWS specific services. Rather, you can go with the Fargate that's much more higher level, more abstraction. But my intention is not to get into that. But my point here is that you realize that in early 2000s, one physical machine for every single web server is not required, or one physical machine for every single Tomcat instance is not required. That's why the concept of virtual machine came in. And later we realized that I don't need really the baggage of operating system with every single Tomcat instance I needed, or every single Apache that I needed. I don't need it. So one virtual machine is enough. Within that virtual machine, you can make multiple containers. So that's where Docker comes into picture, right? So there, the point is you will have one virtual machine. Operating system baggage is not there. You are not carrying that overhead of having multiple operating systems. Rather, within that one virtual machine, you further you'll make it into smaller pieces. Okay, you have your own runtime. Internally, it will manage the ports and make that possible. That's all about the containerization. Okay, it's very popular, still popular. It's still pretty popular, and I recommend knowing container technology to an extent, especially in 2020. But the next level is serverless. You don't even have to worry about the containers and the container orchestration. You don't have to worry about it. Okay, if you're writing a brand new piece of code, just write your piece of code and upload it into AWS and just forget about it. You don't have to manage anything. You don't have to manage your containers. You don't have to manage your EC2 instances. Nothing. They will take care of everything. So no operating system level patches, no runtimes, nothing. You don't have to worry about. You just write your piece of code, upload it, and then just mention your triggering points. When should my Lambda be called? That's all. Make sense, guys? Probably a lot of you have been part of this evolution, all the way from the physical machine to serverless, right? So this is how the industry has been trending in the last 20 years or so. So what are the benefits of Lambdas? Well, no servers to provision or manage. Just write the code and upload to Lambda. Don't worry about how it runs and where it runs. Continuous scaling. It automatically scales your application by running code in response to each trigger. So the beauty here is that as architects, you need to understand 2 points here. One is called in scalability, one concept called vertical scaling. The other one is horizontal scaling. In virtual scaling, you will add couple more CPUs or more RAM. It's a vertical scaling that can only go so much. But the beauty with the horizontal scaling is sky is the limit, because you can keep adding new servers, keep adding, rather than modifying the existing servers. You rather create a new server. That's a horizontal scaling. So always prefer horizontal scaling. So here with Lambdas, the horizontal scaling is what happens. So what happens is when when event gets triggered, your piece of code will be deployed to a Lambda, okay, and then it will trigger that Lambda function. So multiple, let's say there are 500 triggers. So 500 times your Lambda gets triggered. There are 500 Lambda function instances will be running there. Once they give the response back, well, it will automatically destroy that. So you don't have to worry about the destroying also. You're only paying for the number of seconds. It's actually per second billing. AWS Lambda works per second billing. So you will be paying for the compute resources that were used for those many seconds. That's all. And it's a continuous scaling. Automated high availability. Serverless provides built-in availability and fault tolerance, meaning it will automatically distribute your piece of code across all the availability zones, and so that you're fault tolerant. If one availability zone is down, nothing happens. And the sub-second metering, charged for every 100 millisecond, 100 milliseconds. Okay, I thought it's 1 second, but it's 100 millisecond your code executes and the number of times your code is triggered. So it's per sub-second metering. So you are not paying for 24/7 unused EC2 instance, right? And consistent performance. You can optimize your code execution time by choosing the right memory size for your function. Yes, we'll take a look at that. So when you create a new Lambda function, you will specify how much memory does your Lambda function need it. You will specify that, and it will automatically allocate that every single time your Lambda gets called. Make sense, guys? So how does this work? Well, write your code, upload it to Lambda, and set up your code to trigger from other AWS services. So when do you want this Lambda function to be called? Well, when I upload an object into S3 bucket, this specific S3 bucket, I want my Lambda function to be called. DynamoDB is a non-relational database provided by AWS. So when a new record is inserted into this one, I want my Lambda function to be called. CloudWatch, well, when this specific notification, when this particular trigger happens, then I want my Lambda function to be called. SNS, simple notification service. When a notification is invoked, then I want my Lambda function to be called. Kinesis is a stream-based service. So the social media feed, so all the social media feed can go through Kinesis, and then after Kinesis takes all of this stream coming in from all the devices, right? So you can pass it to Lambda, and Lambda will do some work and then could send it to someone else. API gateway. We will be talking about API gateway soon, but the API gateway is nothing but it acts as a front door for all of your web services, especially RESTful endpoints. Okay, API gateway will take the request and forward it to your Lambda function. And that combination, the combination of API gateway and Lambda makes the complete serverless web application, serverless mobile application possible. Lot of new breed of web applications and mobile applications or mobile services that you see are Lambda based, are serverless based. Okay. So yep, Lambda runs your code when it gets triggered. Just pay for the compute time you use. That's it. So take a look at these examples, these use cases, Lambda use cases, before we dive into the example. I pulled it from AWS, the documentation itself. Take a look at this one, how beautiful this one is. A photograph is taken and you upload to S3. So photo is uploaded to an S3 bucket. As soon as it's uploaded to S3 bucket, you can configure your Lambda in such a way that when a new object is uploaded in this specific bucket, I want my Lambda function to be triggered. So this Lambda runs image resizing code. So let's say this is a 4K image, or high definition, right? Ultra high definition image. That is what will be there in S3. And let's say your web application reads from S3 bucket. Okay, you don't need this particular size for every single form factor, right? Like your iPhone, like your phone form factor, like your iPad form factor. You don't need that high resolution because it's a small form factor, right? So what this Lambda function does is, you can write your Lambda code in such a way that you can resize these images. See this one? You have one image size for phone, one for desktop, one for iPads. Photo is resized into web, mobile, and tablet sizes. So that, and now you can leverage them. So it's a triggering point. This is a web application. So this is a beautiful serverless web application. Now, Amazon S3, so front-end code for weather app is hosted in S3. Let's say you have your Angular-based web application is stored in Amazon S3. Okay, so you clicked on all of your static CSS files, JavaScript files. They're stored in Amazon S3, and it's a static static website. It's configured as a static website. But you clicked on something, you clicked on a link, let's say, weather data. Okay, then you're making a call to Amazon API gateway. API gateway is acting as a front door for all of your web services, your RESTful endpoints. This Amazon API gateway can call your can call another HTTP endpoint that may be sitting in an EC2 instance, or it can trigger a Lambda function. Your Lambda function probably can go to your Amazon DynamoDB or your Amazon RDS, Oracle RDS, or MySQL RDS, get the weather data, and then give it back to your Amazon API gateway, and it gives back. We will take a look at this one. I'm going to show you this one, but we will replace this Amazon DynamoDB with RDS, but I'm going to show you this one. And this is a really good concept. So this is another Lambda use case. It's a IoT backend. Your tractor sensors send data to Amazon Kinesis. Kinesis is a streaming service. It captures from various sensors, okay, either your social media feed, all of your, or there could be 200 sensors within these tractors, and there could be 2 million tractors. It's continuously get the stream of data, okay, and then all this Amazon Kinesis knows is that it can take the stream. That's all it knows. Okay, what to do with that data? I have no idea. I will send it to Amazon AWS Lambda. This Lambda will take a look at the events that are coming from these tractor sensors, and then probably maybe temperature is too high. It's giving one of the data points could be temperature is too high from radiator. Okay, why did the temperature that high in radiator? Maybe I look at other sensors data, and then find out that maybe radiator is malfunction. Okay, I can maybe place an order in Amazon, request for a specific part. I can do that. Oh, by the way, you guys, Alexa, right? You guys know Alexa, right? So every single time you say, Alexa, what's the weather like? Any question that you ask, behind the scenes, a Lambda function is triggered. I want you to know that. Okay. Your mobile backend. So you have your mobile application here, and then you deployed. This is a static stuff. Okay, Angular like application. But when you clicked on something, it goes to Amazon API gateway, and API gateway is acting as a front gate for all of your web services. Again, it's like weather service. It can call Lambda, and Lambda can go to other places to get the data and give it back here. It's mobile backend. Okay, and it can even send notification to Amazon SNS, and whoever is subscribe to SNS, they will get notification. Okay, when a status gets updated here, how will this is a simple use case of when I update my status. Let's say I have 100 friends here, right? When I update my status, how are my 100 friends automatically receiving the notification? It's that simple. When I click on status update, it makes an Amazon API gateway. API gateway will trigger my Lambda function, just raise an SNS notification, okay, to status update this a specific particular topic here, SNS simple notification service topic, and all the subscribers are subscribed to this particular topic, and everyone receive their favorite notification, either through smartphone notification or text message, SMS, or email, or whatever that one is. So you can build serverless backends using AWS Lambda to handle web, mobile, IoT, and third-party API requests. So I'm going to show you a simple web service, a RESTful endpoint using API gateway. Okay, but before that, let's perfect our craft with Lambdas. So let's work on Lambdas first. You know, how can I create a simple Lambda, and how many runtime environments that it provides it, and how can I write a simple Node.js code, okay, or simple Python code? How can I do it? Let's take a look at that first. Okay, so it's demo time, guys. So this is what I'm going to do. In my first demo, I'm going to show you this hello world with Node.js. It will code a simple Lambda function and deploy, test it, and we can add some triggers there. Yeah, sure. So I'm going to show you how to write within your AWS management console itself. You can author it. If it's a simple piece of code, right? You don't need a separate IDE. You can write it, especially with things like, especially the runtime environments like Node.js, right? It's pretty simple. I'm going to show you that. So after that, I can show you a simple Java function for S3 events. Okay, we'll code. We are going to write a piece of Java code, okay, a simple Lambda function that will get triggered based on events for a specific S3 bucket. So then I'm going to show you, okay, when you receive the notification, what do you want to do? Maybe I uploaded a file to S3 bucket, right? As soon as I uploaded an S3 bucket, trigger a Lambda. Okay, your Lambda is triggered, and then within a Lambda piece of code, it will tell you, okay, there is a context, there is an event object. So it's going to tell you what's been triggered, okay, what object get added, or what S3 object got updated, deleted, etc. You will get those events, and then based on that, you can go to S3, read the data, and then update your database tables. Maybe if that's what it is, we can do that, and you just deploy it, unit test it with some simple JSON, and then I'll show you how to look at the logs in CloudWatch and X-Ray for it. Okay, so we will do that. And by the way, take a look at this one. Set up Lambda trigger for S3 put events, upload a CSV file with weather data, look at CloudWatch. I'm going to show you this, this demo. I'm going to show you this one also. At least I'll give you the concept, and then you can go from there. You just did most of it. I will show you how to do a simple triggering event. Okay, so Lambda triggers. So who all can trigger Lambda? And going into the exam, it's very important aspect going into the exam. So Lambda triggers. Well, your API gateway can trigger Lambda, your IoT can trigger Lambda, your Alexa skills kit, yes, that can trigger Lambda. Or ALB, application load balancer, can trigger. CloudWatch logs can trigger. DynamoDB. DynamoDB is Amazon's non-relational database. When a new row is created, inserted there, you can have your Lambda function trigger. Your S3, absolutely, S3 events can trigger. SNS, SQS, simple notification service, and simple queue service can trigger. And Kinesis is for streams, and couple more that there actually Lambda triggers. But the most important point going into the exam is RDS is not one of them. Relational database service is not one of them. Meaning, when a new row is inserted into your MySQL or Oracle database, you cannot trigger Lambda for that. I want you to know that going into the exam. Okay. I'm going to show you all these triggers also. Any questions before I jump into the working session? Did you guys understand the concept?
Yeah, Venkat, I have a question.
Yep, sure.
So RDS is not one of them, right? So in RDS, there is Amazon Aurora, which is serverless. How about that?
Yep, even Aurora is not the complete RDS. You cannot trigger Lambda, including Aurora. Okay. Only non-relational database, your DynamoDB can trigger. So let me ask a question here. Anyone has used Lambdas in your current companies, or have you heard of it before?
We know of Java Lambdas, but not the AWS.
Java 8 Lambdas.
Yeah,
I know. So have you guys heard of it, event-driven architecture before? And the power of event-driven architecture. So Lambda makes that event-driven architecture possible. So in the case of event-driven architecture, what happens is when an important event happens, right, it will just event out. It will just say that, someone changed my status, or new object has been created in my S3 bucket. Okay, I'll raise an event. And then whoever wants to do it, all the other people, whoever is interested in my events, they can subscribe to my events, and all I will say is a new object has been created and this is the new object. What you want to do with that object, it's all your problem. So everyone is interested in that data. Someone might respond to that event one way, and someone else might respond to that to the event in a different way. Okay, so that's called event-driven architecture. Essentially, you don't push the data. All you do is you just event out, meaning you just raise an event, and then the people, whoever is interested in it, all the subscribers, they will get notified when an event gets triggered. So it's an how do I put it? It's an interesting architectural pattern. Okay, event-driven architecture is one of the architectural paradigms. So it's pretty interesting. So Lambda makes possible, because Lambda it's a function, right? So essentially that function is there, and you can set up your triggers and say, hey, I want my Lambda function to be called when this particular event gets triggered. So that's the beauty of it there. Okay. So let's do this one. Let's go ahead and take a look at a simple demo. Okay. So if you look at the use cases here in AWS Lambda, so just Google AWS Lambda. That's all. That's the first website. You can go there and briefly read about it and how it works. Use cases here, right? See this one, Seattle Times uses Lambda for this use case, it seems. And then Localytics, some analytics company is using this way. And then Zillow, okay. Zillow uses Lambda and Kinesis to track a subset of mobile metrics in real time. Okay, interesting. And web applications, IoT backends, mobile backends, case studies. You know, these companies, the Coca-Cola company. I thought I read one of this one. Oh, the Thomson Reuters is one of them. Okay, iRobot. Okay. The Coca-Cola company, an American multinational beverage company, used AWS Lambda and AWS step functions to build a cost-effective serverless solution. See that? So a lot of companies actually are going in this direction. And I highly recommend, especially if you're doing in 2020, think about it. Think about your application architecture. So if you already have ready-made code and you are looking for some runtime, definitely go with EC2, but do not EC2 is just one of the options with auto scaling group and others. Absolutely, that works, but give price wise, give AWS Lambda decent consideration. Okay, so go to services here, and then Lambda is obviously, as you expected, it's in compute. So your EC2, let's say Lambda. So I don't have any Lambda functions, looks like. So let's go ahead and create a function. And here it's asking you, okay, hey, you have three options here. Other from scratch, you can start with simple clean slate, or you can use a blueprint, build a Lambda application from sample code. There are some libraries out there. So you can search for hello, use the blueprint and search for hello. See this one, hello world, a starter AWS Lambda function, and the runtime is Node.js. This is a starter AWS Lambda function. This is in Python 3.7. So whatever the programming language that you are familiar with. So let's pick up the Node.js. And of course, you have your serverless app repository, meaning you can look at your marketplace and get some serverless apps. So,
another question, like suppose you have a Lambda function, it's very complex, lot of algorithms involved, and you have a simple hello world example. So billing wise, both will charge same, or?
Good point. So they wouldn't know how complicated your logic is. They wouldn't care how complicated your logic is. How long did the Lambda function been invoked for? So did it take 2 seconds to execute it? Did it take, say, 5 seconds? Did it take 50 seconds? And what's your RAM? How much memory did you ask for when you create the Lambda? Based on that, they will send you the bill. Does it make sense? They don't care about it. That's your worry. Make sense?
Yeah.
So click on hello world. Okay, so we are creating a brand new function, and then I'll say hello world itself. This is my function name, my Lambda function name. So take a look at this one, guys. We talked about IAM role the other day, right? So here, this IAM, your AWS is calling your IAM on your behalf, okay, right? See this one, execution role. Choose a role that defines the permission of your function. To create a custom role, go to IAM console. So if you select this one, create a new role with basic Lambda permissions. So let's say if your Lambda is invoking S3, okay, your Lambda needs a permission to call S3. like your EC2 needing a permission to call S3. Okay. So at that time, what did you do? You created a role and assigned it to EC2 so that you don't have to use your username and password, your user access key and secret access key, right? So you created Lambda and your EC2 instance assumed that Lambda role to call S3. Same way here, Lambda, again, the same thing. If Lambda needs to call S3, it needs to have access to that. Then how can it do that? Well, you can create a new role and assign it to Lambda, and Lambda assume that role on behalf of you. That's the beauty, okay? So here I'm saying that create a new role with the basic Lambda permissions, meaning it just needs to be able to trigger, that's all, okay? So it's a hello world, and this is where the function code is. I will show you. This is the default stuff, but this is your hello world code, okay? Once I click on next or create function, I will show you how to mess with it. So you are creating a simple Lambda function, and it's creating it. There you go. So this is the designer view. This is your hello world. Okay, you can add triggers, and after Lambda function is completely invoked, you can add destination, meaning who do I hand over next after my Lambda function is triggered? It can trigger other Lambda function, or it can raise a simple notification service. So you can add a destination, and here the trigger. So who can call the Lambda function? Let's not worry about the trigger for now. Let's take a look at the code. See, this is your in-browser IDE. See, this is your index.js file within your hello world. And this is your Node.js file. Take a look at this one. So Node.js console.log loading function, you can say, but this is outside of the function though. This is your function. Handler is your function. So this is your async is a function. So this is your function name, but your handler, this is your handler, meaning this is what gets invoked when an event gets triggered. So you have an event and you have the context. So let's say console.log value1 equal to event.key1. You can use your control D to delete the stuff. So I'll say console.log my first Lambda function has been invoked. Okay. You can use your Lambda, and then here you're returning something, your event.key1, meaning your event is your JSON. Okay. There you're expecting a key called key1. You're echoing back. You can do that, or you can even return something like hello world. Okay, just you can do that. That's it. This is your code. And if you are if your piece of code depends on some environment variables, you can define it here rather than hard coding. Let's say your database JDBC URL, usernames, passwords, and other stuff, right? You can externalize them by putting them into environment variables. You can add the tags. Take a look at this one, basic settings, a start AWS Lambda function. So what should I call this index.handler method? See this one? Index is your JavaScript and handler is your function name. So index.handler must be called, and runtime is node 12.x, your Node.js, and memory is 128 meg. So this is what determines your price. So how much memory? You do not have any control over what should be the CPU. It will automatically allocate based on your memory requirements. So here what I'm saying is this particular piece of code needs 128 meg. Okay. So this function is not connected to VPC, sure, and concurrency. So you can say use unreserved account concurrency, meaning how many maximum number of Lambda functions do you want to allow? The default is 1000, but you can change it so that you will have, if you know sort of what your load profile is going to be, so how many invocations you will get, okay, then you can define it so that it's even more predictable. Your performance will be more predictable, but you don't need any of that. So if you want to talk to database, then you can create a database proxy. Okay. So this is your configuration and permissions. Take a look at what kind of permissions. Well, this is your role name, hello world role 3. It automatically created it. Hello world role 3, whatever this new role it's created. Let's take a look at this one. It has a basic execution role. That's all it is, permissions. Okay. Let's go back and this is our summary, Amazon CloudWatch logs, sure. So by action, okay, this particular role, what can you do? This is all good. You have your Amazon CloudWatch logs. Sure, you can create a log group, create log stream, put log events. This is fine. Sorry guys. Okay. This is good. Monitoring CloudWatch metrics. You can take a look at how many invocations happen for this particular Lambda. And yeah. So what we will do now is we save this Lambda function. Let's go ahead and test it. How do I test it? So click on test. So now here, create a new test event. So this is your hello world function. You want to test it with some events, let's say event 1. So you can pass your JSON. This whole JSON will be passed as is to your event. So what I will do is I'll say first name is Venkat. I'm passing a JSON to my Lambda function. Last name is okay. Let's say company. Okay. So this is my JSON and I called it test event. I'll call it test event. And I can't use dashes. Create. Okay. Now I created an event here and let's go ahead and test it. See this one, my execution result, it succeeded. Let's take a look at the details. And what I got back is hello world. The area below shows the result summary. So what happened? My first Lambda function has been invoked. It's in the logs. You can even go to the CloudWatch logs and take a look at it. So what you can do is go to services. If you're wondering, what should I do? Search for CloudWatch. And then once you go to CloudWatch, click on the log groups. And then this is my hello world Lambda. And then this is my Lambda. And then see here. My first Lambda function has been invoked. This is my logs. Okay, everything is good. So now what we'll do is now let's tweak our function a bit. So this is my code. So I just hard coded stuff here, right? As I told you, event dot. What's my input, guys? In my test, I gave first name, last name, and company, if I'm not wrong. Right. So I'll say So I'll say my first Lambda function has been invoked. Sure. What I will say otherwise is hello. And then I'll call event dot first name, right? So my entire JSON payload will be passed as an event. That's all I'm saying. So event dot first name, I said hello Venkat, hello whatever, based on whatever I passed it, right? That's I'm not hard coding it anymore. Let's go and test it and see what gets returned. Hello Venkat has been returned, right? See that? So what I'm going to do is let's edit the test, configure test events. Let me Venkat Hari, right? So I'll change this, my first name to Subbu. Okay, so now let's go and test it. Click on details. Hello Subbu. So your hello world function, based on whatever the payload that you gave. If you give Subbu, it says that hello Subbu. If you give Venkat, it gives yeah. So you are essentially you're passing three things there: first name, last name, and company. So if you want, you can go play with it more. Console.log, or you can say you can create event dot first name. This is your first name space event dot last name. Leave it's constant, constant greetings equal to this one, or you can say full name. Okay, and here you can say hello, your full name, like that. I mean, it's a simple. I don't need to. Did you see that? And then you change your. I think you got the point. We did not see that. Hello, Venkat Hari. It's a simple hello world, right? And you can go back to your log streams and take a look at the CloudWatch and the log groups. And this is your hello world. Oh, probably we are not logging anything. Okay, my first Lambda function has been invoked. Okay. Any other log groups out there? Let's go check. This is the only log group. Okay, these are all the log streams. Okay, the new stream has been created for 9/11, and you can check. 57.92 milliseconds build duration, 100 milliseconds memory size. Okay, memory size is 100 Mbps, 128 megabits. So max memory used is 63 MB. Make sense, guys? So this is your simple hello world. We did not attach any triggers. We just unit tested it, like in a traditional, write a piece of code and then how you unit test it using your, let's say you write a simple Java code and then unit test it with JUnit. That's what you did just now. That's it. But this is not a fun. This is just a hello world piece, right? Now, what we can do is let's trigger this guy. Let's trigger this guy. So let's go back to our functions, and then this is a hello world function, and then we defined it, we unit tested it, we are happy with it. Let's add a trigger now. Okay, let's add a trigger. See, these are all the triggers, guys. These are all the triggers. So my favorite one is, let's go to S3. And do I have any buckets here? Yeah, I have a next step.training bucket. Okay. So essentially what I'm saying is that next step.training bucket, event type. So in this bucket, all object create events or all HTTP put events. Okay. So any of that happens, I want my Lambda function to be called. If you have any specifics, like nope, not all the objects, but any buckets with the slash images slash star, okay, then I want my Lambda function to be triggered. So go ahead and enable it. It's that simple. It's that simple. Now go to your CloudWatch log groups. This is your log group. These are your log streams. What I'll do is I'll just delete these log streams. Okay, I don't have one log. I have one log group and I don't have any streams here. So what I will do now is my hello world Lambda function will get triggered when I update my specific S3 bucket here, right? So let's go to S3. Let's go to S3 and then looks like next step.training. Let me upload a new file. Let me upload a new file, let's say. Now my Lambda should have been triggered. Let's give a couple of minutes. Yep, my Lambda has been triggered. See that? My first Lambda function has been invoked. And then, of course, you didn't do anything with this data. So you didn't take advantage of what the event is, what the bucket is, what the object that's been added. All of that, if you want, you can absolutely get it in the code itself. You will get the combination of your event and the context. You will get everything. It will pass all the details to your event. Okay, and then at that time, pretty much you can read that. You can read the total bucket from S3, and then you can do whatever you want to do it. You can probably parse. You want to parse that into a CSV file and load it into your relational database service, your MySQL. You can absolutely do that. Okay. Any questions there? So Vamsi, your question is, when I write especially with the lambdas, how do I debug, right?
Yes.
So one is with your logs. Okay, you have your CloudWatch logs. You can log as much information as possible in CloudWatch. Okay, so that's the best way. Okay, so Lambda itself is not that complicated to debug, but with AWS, but the interesting point is when you complicate the architecture. So your API gateway calls one Lambda function. This Lambda function calls S3, get the object, resize the objects and put it back in S3 bucket. And then this Lambda 1 triggers another Lambda. This Lambda will take the resize objects and then create these the stamp sized photographs and put it somewhere and send it to some SNS notification, simple notification service. And that guy, some other Lambda function will take the SNS and then happens. So if you do something like that, it's crazy architecture. Pretty much debugging will be nightmare. Okay, it's that's why it's a great tool, but the important point is it's not a silver bullet. Do not want, you don't want to use it for every single use case, especially you take a look at your architecture very closely. But AWS definitely has tools for that. There is a tool called X-ray service. So it provides that X-ray service. X-ray service will give you the complete end-to-end picture of where the payload goes. So, so where did this start from? Okay, it started from API gateway into Lambda 1. Lambda 1 did this one. Then it triggered the Lambda 2. Lambda 2 did something else, and then it called Kinesis stream. And then this guy triggered another Lambda function. It gives you the complete the payload, and X-ray service helps you with that. Okay, and it actually gives you the traces at every single point in a beautiful way. Yeah, so X-ray service will help you, but still I want you to understand it's not the simplest it's not the simplest when it comes to debugging. So one of the you guys know the advantages of the microservice architecture, right? So but there are disadvantages. Every architecture has advantages and disadvantages. In your monolith application, right? In your monolithic application, you have all of that in a single runtime, and you have one piece of code. And when things go wrong, it's easy to debug. But now, if it's scattered across 100 microservices, then it's hell, right? So obviously, microservices has its own advantages. You can scale independently. The scaling requirements are different, absolutely. But you can easily get into this dependency hell. So keep those considerations. Keep those things into consideration for when you are architecting something. So please do not over-architect it. Always, strike the balance between maintainability and fanciness. Okay, and of course, your cost is a major one, but don't over-architect with all the lambdas. Everywhere this lambda calls that calls this one. It's very easy to go wrong with this. Okay, thank you, Vamsi, for asking that, because that's one of the downsides of it. Okay, but AWS X-ray will provide decent option for the end-to-end debugging. To your specific question, how do I debug is CloudWatch. Okay, but end-to-end, how do I get the traceability from the client all the way till all the events across the X-ray service is what you want to use it. Okay. Okay.
Venkat, I have another question.
Yep.
So with this event-based approach, let's say if we upload something to S3 in your example, in my Node.js application, or I have any other application, basically web application, in that application code, should I directly go to S3 bucket? I mean, the code reads directly to S3 bucket, and the event based is only to call that particular Java code, or from the event, like the S3 bucket data, whatever file was uploaded, will it be passed through the event to my Java code?
Yeah, understand. It's a very good consideration. Good question, actually. Nishila's question is, if you guys didn't understand, in general, not only for AWS, specific, in general, in event-driven architecture, let's say I uploaded my PowerPoint to this S3 bucket. Okay, when this event gets triggered, do I send the entire file in the event, or I will just say that a file, this particular PPT file has been uploaded to this particular bucket. Go do whatever you want to do it. What's the right way? The latter. So you will never push the data, because the data could be changed by the time it reaches that subscriber, right? So all you want to do is, all you know is, A file has been uploaded to this particular bucket. This is the bucket name, this is the file name, and you go to it. Make sense? And then that guy will connect to S3, get the file, parse the data, and dump it into relational database service, or however he wants to do it. If that makes sense. Understood?
One question on Lambda compute time. Suppose one is waiting for another Lambda or some other S3 or EC2. So how the time is calculated until it completes everything, time will be calculated, or once it leaves the Lambda function, it stops there.
It's the from the millisecond. It's all in milliseconds, right? So from the point it gets triggered, okay, until the response goes back. Does it make sense?
Okay.
So from the point your request enters, and then until the response is flushed out. Make sense? So this is your hello world based on Node.js runtime environment, right? So let me show you another example here. This is a Java based application, guys. So here I try to show some example in Java because a lot of people are Java, and also I'm most familiar with Java. So okay, so this is your POM XML. Okay, so use your, I've used a Spring Boot starter. It's a simple Java-based Java project, okay, Maven, and what it produces is a jar file. If you look at this one, what it produces is a jar file. I call this Lambda one. And you have your Spring Boot starter and AWS Lambda Java core. This is the library that we have to use it, the appropriate version. Okay, and pretty much that's it. So here, the way it works is similarly here, like in Node.js. So you have to implement this interface called a request handler. Okay, so you have to implement this com Amazon AWS.services.lambda.runtime.request handler. You have to write a class that implements this request handler. Okay, and again, it is giving you the complete event and the context, both of them. Okay, so this is the event, this is the context. And what is event? Event is complete. It's a map of key and value pair. Okay, if I give the first name is Venkat, last name is Hari, company is next step, so your map will be given to you. So your context.getLogger, this is how you can log it, like your console logs, log Venkat's own message, and I can give back HTTP 200 OK, and you can get your environment variables if you want it. But essentially you can get it everything from event. So event.get first name, get last name, you can get everything, and then just give the response back. So what's the response here? I'm giving back 200 OK. So once you write this simple piece of code, this is a Spring Boot application. I wrote my main method. Main method is Spring Boot application.run. So okay. So just create a jar file, upload it, and that's it. Create a jar file and upload it. When you create the function, you can actually run as Maven build. You can do a clean package. Okay, it creates a jar file. C projects Lambda one. Okay. see projects, Lambda 1, and the target. This is my jar file. So this is my executable jar. This is 8 meg jar file. So what I will change a bit here is that I'll change my handler class. Oh, why do I have this application? Is to, if I want to unit test it locally, right? I'll do a run Spring Boot app. I can so I can simply unit test it. Okay, if I want to. So you can create a new function, author from scratch, my first Java function or something. And you can change your runtime to Java 11, Java 8. You can do create a new role with basic Lambda function. Yeah. So for something simple, like Node.js, you can use browser itself as your IDE, but things like Java, you can't do it. So what you need to do is you need to upload your code. Okay. So function code, the code editor does not support Java 8, absolutely. So upload your Java file, jar file, or you can even directly put it into S3 also.
So, Venkat, the IAM role that we create, right? So, should it be created like for every Lambda function, or we can
Reuse
create
it.
once
Absolutely,
and
we can
then?
reuse it.
Okay,
Absolutely,
and
you can reuse
if
it.
we, yeah. So, what exactly is the purpose of it? Is just to trigger from S3, I mean, connectivity from S3 to the Lambda, or I mean, for the authentication purpose?
Nope, I'll tell you. So like your EC2, if you're, earlier we talked, right? One second. So Nishchal asked this question. So we'll create it. Test one. So I uploaded my Java function there, right? Just test it. See, it failed. So class not found, example.hello. So class not found exception. So why did it fail? Anyone an idea? So this is your function code, right? Oops. Where is your basic stuff? See here. So it is expecting the package name is hello. The class name is, package name is example. Class name is hello, and the method name is handle request. So what is your package name? Your package name is com example demo. That is your package name. So put your package name. And then what is your class name? Class name is handler. This is my handler. And what is your method name? Handle request. Sure. Okay. That's it. Your timeout is 15 seconds. Makes sense. Okay, now test. Oops, we changed. What happened? Com example demo handler handle request. Class not found exception. Java 8. Let's go edit. This is two exclamation. What happened? Execution logs, class not found. Com example demo handler class not found. There you go. Com example demo handler class not found. Okay. So something wrong. The deployment package of your Lambda function, my first Java function is too large, enable inline coding. Makes sense. Okay. Let's take a look at COM example demo handler, right? So this is your jar file. I wanted to take a look at the jar file, target. This one abused Spring Boot.
Maybe you could try open with WinZip or something if you have any.
Yeah, I'll use a untar or unjar. Now the point is, this one I've used Spring Boot, right? Actually, let me see which one. This is S3 event notification. Okay. So let's do an untar. If you guys, jar is not recognized. Okay, boy, I don't have the environment set up. Huh? Okay. So I want to take a look at this guy. So let's see. I don't have any zipping also. Okay. Okay. Let's see. Okay, so jar xfv C projects Lambda 1 target. Oh, sorry. Lambda. Okay. So within your classes, com example demo handler, right? Yeah. Okay, let's take a look at it closely. Com example demo handler. Nothing wrong here really. This is my method name. Package.classname : handle. Yeah. Or package.classname. For example, com.hello : my handle calls the my handler method defined in hello.java. Yeah. Com example demo handler. Okay, let's take a look at we uploaded. Configure test events, first name. Okay. This is all fine, I think. Example number 100, java.class. Okay, let me take it offline and then see what it is. I will take a look at it. Okay, so I'll take a look at it. Meanwhile, actually, I'll take a look at it right now. So can you do me a favor, guys? Let me pause record. Okay, I resume recording. Okay, anyways, so what am I saying here? So yeah, cancel it. So as I mentioned, so I picked up the wrong Java project here. Actually, maybe I'll even delete it from the video. We'll see. So anyways, the point is, this is a simple Java-based project here. So you have your, so for Java-based projects, or your C# based projects, any of these object-oriented programming languages, right? So you will have to implement an interface. That interface is nothing but just pure contract. Okay, so you will have to implement that interface and provide the implementation for that. So I said, I got the logger. I said my first Java function has been called. I got the first name, last name, company from my event. Okay, and then simple hello world, right? And then I ran as Maven build clean package. Yeah. And then once I get it, let's create a new function. We just created a new function. I uploaded the code already. So how do I do that? Probably I can start again. Not a big deal. Create function. My first Java function. Java 8 as runtime and create function. Since it was not in the recording, I'm just doing it again. Okay, so go down. Where is your function code? Actions, upload a zip or jar file. This is my jar file. Save it. Your 6.7 meg file will be uploaded into your AWS Management Console. Go down, basic settings, and you have to specify your fully qualified class name and method. Fully qualified class name meaning you have your package name dot class name. Package name dot class name. My package name is com next step lambda, and handler is my method class name, and handle request is my method name, and I want 512 meg memory for this, and my timeout is 15 seconds. So this is good, guys, and I think we saved it. Let's go ahead and test it. And so we'll create a new test event. I'll call test1, and I'll what am I looking for here from input? Input is a JavaScript object notation file here. See here, this is a JavaScript object notation file, and give me first name, give me last name, give me company, and that's how it works. Okay, well, see, what's your last name? Like that?
Yeah. Yes.
And your what company do you work for?
USA Bank.
Like that?
Yeah.
Okay. create, and then test it. So hello, Vamsi Kari. So you work for USA Bank. Excellent. That's it, guys. Okay. So my first Java function has been called. You can go to your CloudWatch. You can go to your CloudWatch. Go to log groups. There you go. What's my function name here? Something like my first Java function, something like that. My first Java function. So my first Java function, and it's 940. I think this is a previous one probably. My first Java function, there you go. 1002. Yep, my first Java function has been called. Very good. That's it. So that's about Hello World with Java. Any questions? So we saw Hello World with Node.js. We saw Hello World with Java. I will show you another interesting interesting aspect. But before that, let's attach a trigger to this guy. So we created a function and unit tested it, but we did not trigger anything, right? So you can create a trigger. You can go to S3 and again bucket name, next step training, all object create events, all of them. I want my Lambda function to be called. Oh, because it's already associated with something else. That's why it is saying, you can't attach both. So what we will do is my first Java function will okay, that trigger is gone. Now my first Java function and the trigger S3. That's it. So now when you upload something into S3, your piece of code will be called. Okay, that's it. It's that simple. You can test that. Since this is a hello world, even though you upload it into S3, you're not getting any of that, right? So yeah, it's nice hello world, but not real world use case, right? So let's pick up a real world use case here. So S3 event handler 1. So this is my use case here. So what this guy does is, again, your class must implement this interface called request handler. And this time I'm taking this S3 event notification as an input. So S3 event notification is an object provided by your Amazon, your AWS Lambda library. Okay. So the way we wanted to do is S3 event notification, when you get the input, so you can get the records and get the first record and then S3. So you will get the complete S3 entity there. So when an event is triggered, when an S3 event is triggered, you can, from the event, you can get your bucket name, what bucket has been changed. This is my bucket name has been changed. Okay, what object has been created or updated or deleted? This is your object key. The combination of bucket name and object key, you got it, and now you can do anything about it. Probably you can go to S3 using your Java piece of code. Using the combination of bucket name and object key, you will be able to get the object contents and parse it and load it into your RDS, load it into your DynamoDB or whatever you want to do it. Does that make sense? In fact, is this not the question that you were asking earlier, Nishila? So
Yes.
Right.
Yes.
In your event, this is how you get the event. Okay. So you can get the complete, records. And for each for each object, bucket and object key, you will have a record. So when you upload an object, or when you update an S3 object, or when you delete an S3 object, your Lambda gets triggered. When your Lambda gets triggered in this particular method, okay, you can get the metadata, like what's been changed. What's been changed? Well, my bucket name and object key. Okay, give me those two. Understand? So this is your next level, guys. So what we will do is, let's if you guys are okay, I will run this guy and create an artifact. I'll call it clean package. Create the clean package. S3 event handler 1. And these projects should be there in GitHub, guys. I open, all of my work typically is open sourced. All my projects are, open source, so you can get it from GitHub. So, I mean, for you guys, even if it's not open source, you'll get it, but I'm just saying in general. Okay. So what we'll do is create a function. Let's say my Java S3 function. So you can go down and you can upload your function code. S3 event handler 1, target. This is your jar file. Your 5.9 meg jar file will be uploaded there. Okay. So yeah, that's it. And then update your basic settings. And what class are you calling? Com next step Lambda. S3 event handler. And then handle request. No, I think that's same. 512 meg. And so here, event templates. Sorry, I want to unit test this one, guys, right? I want to unit test this S3 piece, right? So when you click on test here, event template here, look for S3. Okay, see this one, Amazon S3 put. Okay, see this one here. So create a test event. We will play with it together. S3 put S3 test one. I'll call this event name, and then let's play with this data now. Okay, so take a look at this one. So when you play with S3, this is what, when an event gets triggered to your Lambda, this is what Amazon automatically gives you. That Amazon will automatically give you a JavaScript object notation, your JSON file. Within the JSON file, you have a records. Records is an array. Within that, you have a multiple records. This is one record, okay? So within this one record, it will give you event version, event source, what region it triggered on, event time, when was this triggered, what event is that, is it object created, put, user identity, principal ID, all of this will be given to you, but we are mocking this data. All of this object will be dynamically will be given. If you understand that, we are trying to unit test our piece of code, guys, with some dummy information. We are passing this dummy information as if Amazon passes at runtime when I update my S3 bucket. Are you guys understanding what I'm trying to do here? I'm trying to do a unit test. Okay. So within this, see here, input dot, meaning this whole, this is how Amazon is going to give me dot records. So I got the records, get 0, meaning the first record. Okay. Within that, dot get S3, meaning I'm asking, give me this object, object here. So once I get the S3, I'm here within that, get me the bucket and name. Where is the bucket? Bucket is another JavaScript object notation, JSON file. Within that, you have a name. So here I will call it next step bucket. Okay, just I'm giving some dummy name here, bucket name. And then within the object key, I will call it google.jpg, something like that. Okay. In this bucket, this is the bucket name and this is the object key. This is what was changed. What is changed here? A put object put, meaning a new object has been created is what I'm saying. So let's go ahead and test it. It gave back 200 okay, because that is what I'm giving it, 200 okay here. Okay. But inside that, looks like I didn't put any good, oh, I gave this log, right? Bucket name equal to, where is the bucket name equal to? Handle request has been created, bucket, yep, bucket name. See this one, bucket name equal to next step bucket, object key equal to google.jpg. Okay, that's what has been given. So now this is with the dummy data. I don't want the dummy data. What we will do is, let's go there, let's add a trigger. Let's add a trigger now. Let's add an S3 trigger. And we will say next step training, all object create events. I want my S3 bucket. I know it's been already with someone else, right? So let's go change that guy. My first Java function. My Java S3 function trigger.
So Venkat, for each Lambda function, I mean, for one S3 bucket, I can do get, another one, can't I do put, and I mean, I cannot define that because it's the same S3 bucket?
The events, you cannot have multiple events, but if you want to do it, what you want to do is you have to have your raise an SNS, subscribe to have one event for S3, but internally raise a simple notification service and then subscribe to simple notification service and do it. In the real world, that's what you do it. Okay. I'll probably cover that. I'll show you one of these days. So anyways, the point is, this is your next step training bucket, right? So let's do something now. Where is your S3? This is your S3. Let me upload a simple, let's say my notes somewhere. I uploaded my notes, right? So notes.txt file. Now let's go to CloudWatch logs and then say my Java S3 function. Let's go take a look at it. See this one, guys? My bucket name is next step object key google.jpg. That was previous one. Now see this one, bucket name is next step.training. Object key is notes.txt. This has been, so the entire event details have been passed by AWS to your Lambda function. And in your Lambda function, you took out those details and you asked, hey, give me the bucket name. How do you get the bucket name? Well, this is how, because AWS is going to give you in the form of array of records. Within that records, you're taking the first record, meaning first every event, it's one record. right? Within that, you give me the first event and go to S3 JSON object. Within that S3 JSON object, give me the object name, bucket name, give me the object key. You got both of them, you just logged it. That's exactly what you got it here. I know what we did is not much here, okay? But an important point is being answered here. How do I get what S3 bucket the event was triggered on? What was the object that's been created or updated or deleted, okay, that caused my Lambda function to be called? We are able to get it. Once we get it, everything else is a piece of code. Everything else, we know that. We know how to use S3 SDK. Once you get the bucket name and object key, pretty much go to that bucket name, go to that object, get that object, parse that object, store it into your RDS or store it into your non-relational database. Does it make sense?
Hey Venkat, I have a quick question. Yep. So here we are getting the list of records, right? That means if we upload multiple files or update multiple objects in the S3 bucket, so it's gonna just fire only one event rather than the multiple events for each object.
At a single time, at the single time, if you do multiple, yes.
Okay.
In a single event, when you have a multiple, so then you'll get multiple, yes. So that's how you get it. So now, once you get the metadata information of it, now we're going to the next level now. Now take a look at this code here. Now the next level is, let's take a look at this S3 event handler. Let me explain the situation here. Is I have my weather data here like this. I hope I have a weather data here. Yeah. So my weather data is like this, guys. Okay. I did this for my previous session. See this one, this is a zip code and this is the corresponding temperature. Some temperature is, some of them are in Fahrenheit, some of them are in centigrade, etc. So essentially we are a weather company. We hold the data, okay? We will have the temperature for each zip code. That's our domain. We are a weather company. Make sense? So the idea here is that we have a robust API. We have a robust APIs that we expose. So anyone can call our API and they can pass the zip code and we will give the temperature back. As an example, iPhone has this API, iPhone app called Weather App, right? Weather App, do you think Apple owns the data? No, they're making a simple REST call to Yahoo Weather Service. So Yahoo is the one that's providing the data. It's just, Apple is just providing the skin, all the fanciness, that's all it is. Under the hood, Yahoo is providing all the weather services. So we are like Yahoo here. You give me the zip code, okay, based on your current location, you pass me the zip code, I'll provide the temperature. Make sense, guys? That is our domain. That's what we do for living. Let's say in this example, yeah. So we get the weather data from somewhere, from all of our agents. Maybe all of our agents are there, across the country. We get the weather data every 2 hours or 3 hours. So when we get the data, we get this in the CSV format. So when we get the data, what our analyst does, analyst is not technical person like you guys. Okay, analyst is not technical. What he or she knows is that when he or she gets this weather data, all he knows is that go to S3 bucket here wherever that one is, go to that S3 bucket. Let's say there is a bucket called weather, right? Go to S3 bucket and upload the new weather file. That's all he knows, because he's not a technical guy. Okay, he will upload it. So what our piece of code does is, we wrote a Lambda function that gets triggered when you upload a new object from on this bucket. What we do is, our Lambda gets triggered, and our Lambda will get the notification what object has been uploaded, what's the object key, okay, what's the weather data file name, and what's the bucket name. Using those two pieces of information, we will go to S3 using our piece of code, Java S3 SDK, get the data, get this CSV file, we will parse it. Once we parse it, I'll get the Java objects, right? This is a zip code, this is a temperature. I'll get all of this one. Now this one, this is the brand new data. This is the brand new data that I just received. So, but what I have in my database is old data. Like I told you, the weather data changes every 3 hours. We get the data from all the agents every 3 hours, right? So what our Lambda code should do is delete all the records from a table, temperature lookup table. Okay, delete all the records and then parse it and load it into it. Now we are good. Now we'll get the fresh weather information. After 3 hours again, our agents would have accumulated all the data into CSV and send it to our analyst, and analyst will upload it into S3 bucket. And S3 bucket, once it gets uploaded to S3 bucket, our Lambda gets triggered. Our Lambda will get that object key and S3 bucket name. So using both the piece of information, again, it makes an S3 call, HTTP GET call, get the new CSV file, parse it, and load it into the database. Once it is loaded into the database, there is an API already. That API will read from those database tables. Now, when these iPhone apps or Android apps, they call the REST APIs, they get the fresh data. The data gets refreshed every 3 hours. Did you understand the use case here, guys?
Yeah, Venkat. Yeah, makes sense.
So that's the intention. Now, how do we do it? I'll show you how to do that. So our Lambda here, S3 event handler, request handler, has been called. Again, the reason we did the previous example is for this one, to complicate the things. So I got the object name, bucket name, and object key. I loaded it. Now, using the bucket name and object key, I'm calling this class called weather data retriever dot get weather data. I'll give you the bucket name and object key. Somehow give me the weather data. This guy will go to S3, load that CSV file, parse that CSV file, and give me as a list of these weather objects. And once I get the list of the weather objects, then I will call my DAO, data X object, or a repository pattern, meaning my database guys, right? I'll say insert new weather data. This guy will delete the old records and he will load the new records. That's all it is. So let's take a look at this retriever.get weather data. Give me the weather data. So essentially, I'm doing a simple Amazon S3 client builder. We did all of this before, right? And bucket name and object key, bucket S3 object, stream reader. We get the CSV file, and I'm using this CSV record. I'm using Apache Common CSV here. Okay. I'm looking at each record in the CSV file. First one is a zip code. The second one is a temperature. And then I'm created a weather object, set zip code and set temperature. I have this object called weather object and loading into the list here. And then I got the list of weather objects. From this CSV file, I got the list of weather object, and the weather object has two attributes. zip code and temperature. Once I get both of them, I'm giving it back to the caller. All caller is doing is it's calling that weather data setup repository and then insert weather data. You take a look at that. You have your RDS details here. You have your database JDBC URL. You have your driver, admin, and whatever, username and password. Ideally, you don't want to put them in the code. Lambda has a feature called environment variables. For pull them out to environment variables. Where is my Lambda? See here, there is an environment variable here. So define an environment variable here. Add an environment variable. It's a simple key value pair and read them. How do you read your environment variables in Java? Your system.get property. So your Lambda will automatically give you that. So ideally, you shouldn't hard code them here. You should put them, as an environment variable. But mine is just an example. You got as long as you get the idea, I'm happy. That's all. So using all of this one, you connect to your database, driver class, URL, username, password, JDBC template. This is a Spring JDBC template. And I'm deleting all the weather data records from the database table completely. And then I'm doing insert into weather values equal blah, and then putting in a, for all of this list, I'm doing a batch update for zip code and temperature. And then that's it. I'm just doing a batch update, meaning I'm inserting it, deleting all the weather records and loading it again. That's all I'm doing. Very simple code, piece of code. So any seasoned Java developer, it's not a big deal. It's pretty straightforward. But other people, I know a couple of people are here who are not familiar with this level of Java libraries. Okay, understand your point, but you don't need it. Understand the concept, because it doesn't matter whether it's Java or Python or Node.js or something else. As an architect, in fact, this is not needed for your exam. This is not needed for your real, you are playing an architect role. You don't need this low level stuff. But I wanted to show you guys, because that's where the kick is. Once you do that, once you connect all the dots, that's when the real kick is. That's all I wanted to show you guys. Make sense, guys? And I have this in my GitHub next step training. Let's see if you Google that. I can pass that. Okay, next github.nextstep.training. Go there and you will see my repositories there. Click on repositories. So S3 event handler 1, S3 event handler 2. This is the one that we talked about. You can load it into it. So, okay, looks like I wrote some README prerequisites. Provision an RDS instance with MySQL. Create following table in the table in the database. So you need to create this table. Create table weather.temp lookup, zip code, varchar of 10, varchar of 10. Steps. Go to weather data setup repository Java code, which is this one. Go there and then change database details to match your values. Okay, these ones, change to match you. Run Maven clean package, create Lambda function, name it S3 event handler 2 or whatever you want to name it. Upload your jar file, configure your Lambda handler as this one. See here, your fully qualified package name, .class name, and your method name. Make sense, guys? Is there anything that's confusing? Pretty straightforward, right?
Yes, Venkat.
Are you guys able to appreciate it now? Because you may be initially thinking that S3, okay, I'm uploading the files using browser, all of that, how can I really take advantage of it in my enterprise world? Now you have a piece of code that interacts with S3. Now you learn the concept of the lambdas. Lambdas get triggered when an S3 event happens. And you can write a piece of code that does all of this orchestration. Beautiful, right? And we will see there's another one called API Gateway. API Gateway is an API concept. So with that, you can actually build a serverless web application. That's exciting too. Same stuff, you will write multiple lambdas, but those lambdas will be called not by S3 events, but actually API gateway. Meaning, when I make a when I make a call to weather.com / let's say my zip code 480.480.48083, right? When I call when I make that HTTP REST call, that has to call my Lambda function, and my Lambda function should go to the database, get the data, and give it to me. That's the fun. Yeah. And if we can glue that into your static website, you have your Angular app, and then glue these APIs into that. That's your dynamic web pages. That's exactly what you guys are doing it at the enterprise level. And these are serverless websites now. You're not maintaining any EC2 instances. You are not, no application load balancer, no auto scaling group, no, all of that is previous generation. Now we are talking in 2020. Make sense, guys?
Yeah, sure, Venkat. And I have a question. Like, we have used this IAM role, right? Where will we use that in what context?
So IAM role has been created and assigned to your Lambda function, okay, all along. But so far we did not. So far, if you really look at your Java functions, your function here, right? Permissions. So this is the role name that, okay. So what do you have here? And all you have is okay. So you have this particular policy. So you have a simple, so this has been attached to your Lambda, okay? So all you can do is you can do an invoke function. That's all you can do, right? Also, you can allow making an HTTP calls to your s3.amazon AWS, your S3. Now, if you need more, okay, how do you make a call if it is private? Okay, if it is private data, right? So you have to provide your access key ID and secret access key, right? Without providing, how can you do that? Well, we talked about IAM role, right? So what you do is, I would say the best big bang for the buck is create a new IAM role and give all the access needed. One is ability to invoke a Lambda function, give that, okay? Give that. And also ability to invoke S3, allow that, okay? And any other functions that you need it, or also the CloudWatch, okay? CloudWatch logs, ability to create the log group, ability to create the log stream and put log events, give those, okay? And create a role and assign that role to your Lambda. If I mess with this role, Okay. Click on this guy. Okay. So if I change this one here, right? Let me go to this one. So this is what has been given in my AWS Lambda basic execution role. This particular role, this is the statement here. So you have a create log group allow, create log stream allow, and put log events allow. Okay. So that's all. So if I mess with this one, and if I take out this one, for example, right? If I change it to deny, then what happens is your Lambda function will not have access to write it into your CloudWatch. That is the effect. Your Lambda function is a compute resource like your EC2. If your EC2 needs to talk to an S3 on your behalf, your EC2 instance has to assume that particular role. Agree with me so far?
Yes.
The same thing has to be done to your Lambda also, because your Lambda and EC2, both of them are compute resources, compute services. Sorry, right? So both of them can assume an IAM role, and then they are invoking S3 on your behalf. Understand that? They are invoking S3 on your behalf. They are invoking other services on your behalf. They are they're putting the log events on your behalf. You have to allow that. If you don't have this one, if you take out this one, then you'll not be able to see it. So that role is what, see, this one is the role. And now if you want your Lambda function to create an S3 bucket, okay, then obviously you have to edit. Where is your use an existing role, create an, now you want to change your existing role. This is your use an existing role, right? You can create a role from AWS policy templates or S3 full access, or these are customers. Okay. Create a role. So you can create a role, and then, you can get your S3, Amazon S3 object read-only permissions. You can go to IAM and create a brand new role and come back here and assign it to your Lambda function, and your Lambda function will assume that IAM role on your behalf and call it. So if at all you are not able to see the logs in your Lambda function, then what could be the reason? It's your role. Does it make sense?
Yeah, got it. Yeah, I was thinking, like, I mean, if the bucket has have only read-only permissions, we didn't have access. We didn't give any user to basically perform any other actions. Then if these event-based kind of roles, how do they link to each other? I mean, each other conflicting, like IAM roles. Basically, that's the scenario I was looking. But I think this is just to IAM from the Lambda perspective is just to allow or deny basically the bucket, right? That's the level, right? I got it.
So again, since we are mixing a couple of services, not only for you, but I wanted to make this clear for everyone. So understand it. You have a compute service like EC2 and Lambda here, and you have a role here. What did we talk about? So essentially, you have your IAM policy. That is the lowest level. IAM policy will say what can you and cannot do. That's what IAM policy defines. Agree? Now, bunch of IAM policies, you can create them, and you can create your own custom role. Now, you can give that role to a person. When that person is doing it using his own credentials, okay, he will have the permission to do that. Or now you can give this role to an EC2 instance. So your EC2 instance will assume it on your behalf. So EC2 instance will be able to do these things that are defined in that role. Similarly, the role here, you are attaching that role to your Lambda function. And now the Lambda function will assume the role on your behalf, and Lambda function will execute it on your behalf. Does that make sense? No confusion there, right?
Yeah.
Is there any confusion? This is your execution role. Just wanted to make sure. So, okay.
And Venkat, on
go
the
ahead.
top, if you see, there is throttle, qualifiers, and in
Yes.
the action tab, there is create alias and other publish, export. Export, I think, makes sense because this is created in one region. You can export this, maybe import. I don't know what's the export feature, but I was just asking those.
Yeah. So you can, the lambdas are region specific. Lambdas are region specific. So it will automatically take care of your auto scaling within the region, okay? But they are not cross regional. Actually, most of the services are not cross regional, right? So the export and export function, that's what happens because you'll be able to import it. Okay. And again, Lambda function, you'll be able to publish the newer versions without, by leaving, it's like a way to manage version control for your Lambda functions, essentially. That's all it is. And throttle, yes, you can throttle it. So this action will set the reserved concurrency. So we talked about, there is a reserved concurrency here. See this one? So when you use this unreserved account concurrency, meaning across all the Lambda functions for my account, okay, so 1000 concurrent function invocations is how it throttles by default. 1000 concurrent invocations across the account. It's not one Lambda function, it is across all of them. Because I've been mentioning that there are no servers and Lambda is a serverless concept, totally. But under the hood, what happens? Under the hood, there are servers, right? That Amazon manages. You don't have to manage it. Under the hood, there are some servers. And actually what it does is when you invoke a Lambda function, if there is no container out there, it will create a very lightweight container and deploy your code into container and then invoke your Lambda function. That's what behind the scenes it does. So essentially you can throttle it. So you can set the limit that this particular Lambda function cannot cross these many numbers. You can specify that. I do not want more than 100 invocations to happen concurrently for this particular Lambda function. You can throttle it. Okay. So, and then you can say the reserve concurrency. If you have a general idea of how many concurrent invocations happen for your account, you can go with this reserve concurrency so that your performance will be more predictable, because Amazon will keep those servers handy and then make them readily available for you. Okay, and then your function will be throttled, if you keep the reserve concurrency. Meaning it will not let more invocations than your throttle. Okay, so I was hoping to actually talk about API gateway also, but I think it's not fair now. So what I want to do is I want to leave decent time for you guys. So I want you to play with it. Then you'll be able to appreciate your API gateway tomorrow. Okay, API gateway is an interesting concept. Okay, whether it is lambdas, you don't need this depth. You don't need this kind of examples for the exam, guys. Okay, you don't need it. So exam is slightly different. They focus. I can help you. I will guide you there. But this is a real world. What I'm showing you is a real world examples, real projects. This is exactly what we do. This is how we skin it, you know. And this is how I want you to experience also. Okay, you don't need it. For the exam perspective, this is lambdas. Typically, any Udemy codes or any other codes that you see, they talk about it 5-10 minutes and done. Then for the exam, understand what it is and what's the advantages, and just move on. And the triggering points, that's important for the exam. Okay, so let me stop recording.